Greetings, Dr. Will here. Welcome back to the serialization of What You Don't Know, Successfully Lead a Software Project Without Tech Expertise. Episode 18, Chapter 7, Making the Abstract Real, Code, Test, and Deploy, Part 3.
Depending on the size and complexity of the module, unit testing can be a significant undertaking. Small programs spend proportionally more time in code and debug and unit test than larger programs. Smaller programs have fewer components to integrate, and smaller systems have less functionality to test. Larger systems spend more time on architecture and design, integration, and system tests. An MVP, however, should appear to spend a disproportionate amount of time in integration and system test because it is a small subset of a much larger program. It is a large system being built and integrated with very early delivery of architecturally and business significant uses. Integration testing. The different parts of the system are brought together, composed into a larger system. The integration itself can proceed in different possible orders, and the integration order is primarily defined by the system architecture. As the components are brought together, the interfaces between the system parts, modules, components, subsystems, are tested. The developer will usually perform integration and unit tests before releasing the module to the tender mercies of the team. In larger systems development, the team ensuring system quality will repeat and extend the integration testing performed by the developer. Larger scale systems will need to follow an incremental integration strategy of some sort. An MVP of a SaaS product is part of a larger system. The fact that it is intentionally delivered with partial functionality and plans to build out the rest of the functionality will, by definition, be incrementally integrated. A small-scale system can be integrated in so-called Big Bang integration. That may result in a large number of complex problems to solve. If that happens, then it makes sense to back up and try a slower, more systematic, incremental integration process where issues can be addressed integration stage by integration stage as the system is composed into its final form. System testing. All of the components, hardware and software that make up the system are integrated and tested to uncover errors from unanticipated interactions of the different system components. The system test also validates that all functional and non-functional system requirements have been met. User acceptance testing. To be actual requirements, it must be possible to validate that the finished product satisfies them. The User Acceptance Test, UAT, is a suite of tests demonstrating that each of the stated requirements is present and working as expected, or at least as specified. And yes, sometimes expectations and specifications turn out to be two different things. Non-functional requirements may be difficult to validate. Any non-functional requirement that cannot be expressed quantitatively will not be able to be measured. And if it cannot be measured, then it will be difficult to validate. Acceptance testing is the final testing stage before the customer accepts the system for delivery and operational use. The system is tested using data supplied by the customer rather than simulated test data created by the developer to exercise the system. Often the acceptance test is performed by the customer while the developer observes. A particular case of acceptance test is alpha and beta testing. These are unstructured, unplanned tests by a broader group of customers and are not conducted under the supervision and watchful eye of the developer. It is a sad fact that many software projects rely on their customers to do the main body of testing in the form of alpha and beta tests. This is the mark of a pathetically bad or underfunded development organization. Deployment. Deployment is putting the working system into its production environment so that it is usable by its end users. The initial deployment may be relatively simple. The system is rolled out, put on the servers, checked out, that is exercised as if it were a live production system, and then put into service. Voila! In the beginning, there is little or no data in the system. It stays that way until it starts getting some use, some wear and tear. If the deployed system is successful, then it will be subject to many changes. See Chapter 8 on software maintenance for more information. And if the system is an MVP, then there will certainly be many follow-on deployments as additional features are added. A successful system will be changed, updated to add new features, address new markets, and fix defects that slip through the cracks in the development process. Unsuccessful or marginally successful systems will be changed too, but with more of a sense of despair and panic, and a swiftly dwindling pile of cash. Subsequent deployments may be simple, but are likely to grow increasingly complicated as changes to the application are reflected in changes to the data. This may necessitate creating and testing a migration utility to update the data structures in the existing production environment. Depending on how deep the changes are, you may be stuck with a lengthy upgrade process. Each deployment should be validated before go live. If a flood of errors happens as soon as the system is made the live production system, then it may be necessary to revert the system to the status quo ante and figure out what went wrong. A more subtle error that corrupts data, let's say, may go undetected for hours or days. In that case, reverting to the earlier version might not even be possible, and the system must be fixed on the fly. We are spoiled by systems that seem to upgrade seamlessly, new desktop operating systems, for example, but they result from intense engineering efforts and proper planning and testing of the deployment process to ensure the seamless transition to the latest version. DevOps. A relative newcomer is the field of DevOps. Yet the word DevOps is a portmanteau created from development and operations. It is a set of practices intended to shorten the system development lifecycle and continuously deliver high-quality software. DevOps are complementary to Agile development methods and inherited much of its approach from them. DevOps are characterized by shared ownership of the project, workflow automation, and rapid feedback. It combines practices, changes to the culture, and tool chains. Practitioners use different tool chains as part of their cross-functional discipline. Reflecting critical aspects of the development and delivery process, the tool chains are drawn from one of several of the following categories. First, coding, code development and review, source code management tools, and code merging. Second, building, continuous integration tools which reflect build status. Third, testing, continuous automated testing tools that provide quick and timely feedback on the business risks. Fourth, packaging, artifact repository, application pre-deployment staging. Fifth, releasing, which is change management, release approvals, and release automation. Sixth is configuring, or infrastructure configuration and management, and infrastructure as code tools. And finally, seventh, monitoring, applications performance monitoring, and end-user experience. The workflow automation ties the relevant tools from these categories into tool chains that improve the efficiency of the integration, test, and deployment of a system.
That ends Chapter 7, Making the Abstract Real, Code, Test, and Deploy. Join us next time for Episode 19, Part 1 of Chapter 8, Protecting Your Investment, Maintaining Software. That's it for me, for you, for now. Be careful out there. Bye.